I'm Andy. This is me. This is my Lego me. I'm a Lego fan. And I work for a new company called Pivotal. How many of you in the audience were at Guillaume's Groovy talk yesterday? Anybody? One of you, two of you? OK, a few of you. OK. So Guillaume and I both work for this company called Pivotal. I'll tell you a little bit about that in a second. First of all, I'll do the little boasting about me thing. This is me. My job is developer advocate for Cloud Foundry. So I'm doing this talk right now. This is my day job. I'm going to talk about what I do for a living. And then later on this afternoon, I'm actually giving another talk on something called MQTT, which is a lightweight messaging protocol for the Internet of Things. That's my hobby. That's my side open source project. That's not my day job. Here's some contact information for me, my Twitter handle and my email address should you ever need to drop me a line. So developer advocate. Many companies have developer evangelists. Developer advocate, developer evangelist, very, very cool job. I love it. But the really important thing from my perspective is that I'm not here just to stand here and kind of preach to you and tell you how awesome our platform is. I'm actually here to answer questions and to take your feedback. So I'm on your side. If I'm not making stuff clear, if our website doesn't make stuff clear, if our platform doesn't work for you, if things are broken, etc., contact me. I will go and beat up the engineers. Admittedly, most of them are on the west coast of the US, so it may take me a few weeks to actually get over there and hit them for you, but I'm here to do that. And I really love the role. So I mentioned Pivotal. A number of years ago, a company called VMware acquired a company called SpringSource, and that was a marriage made in heaven for a few years. And then they acquired some other things like RabbitMQ, and they hired the guy that writes Redis, and VMware and open source, and it was all very fun. But VMware is a proprietary virtualization platform. And that's also partly owned by, the company's partly owned by EMC. So at the same time, we were kicking off a load of interesting open source projects like Cloud Foundry. What we decided to do, what the two companies, EMC and VMware, decided to do was to spin all of this activity into a new company called Pivotal. So we've actually only been around since May of this year as a standalone organization. But as you can see on the chart here, we've got a lot of very, very cool open source technology in our kit bag. A lot of it's Java-based, such as Groovy and Grails, TC Server Tomcat, and Spring. But we've also got some big data technology. So we've got a Hadoop distribution called Pivotal HD, and RabbitMQ. Many of you, I'm sure, have come across Rabbit or Redis and are using those kind of technologies. And the other thing that we do is our cloud platform, Cloud Foundry, and that's what I'll talk to you about this morning. So important information if you're going to be tweeting or writing about this session, my name, the thing I'm talking about, and the company I work for. There we go. Introduction done. So just to give you a little bit of a direction for where I'm intending to take the conversation this morning, I want to start off at the beginning by just talking about cloud platforms generally, and in particular, open source. Then I'll give you a brief intro to Cloud Foundry, what it is, what it does. And then the majority of the talk, which is obviously what you've come for, is focused specifically on our Java support on Cloud Foundry. So let's start off by thinking about open source and open clouds and so on. And this is actually something I feel really quite strongly about. Anybody, this is one of those sessions that I've been to a few sessions in this room where there's been some attempts at interactivity. I'm going to try it again. Anybody want to tell me who wrote this in '91? Absolutely, Linus Torvalds. You know, this isn't going to be a professional, big thing, Linux. It's just some code I've written. Have a look, see what you think. Now, you know, 1991 actually is just over 21 years ago. Linux is now kind of an adult, right? It's grown up. And all of a sudden, Linux is actually everywhere, right? Linus never intended, or especially when he wrote that email, never expected that this would happen. But it's everywhere. It's, you know, it's the basis for things like Android. It's on, you know, airline entertainment systems that crash and reboot in front of you. That's fantastic. Always nice to see that happening on a transatlantic flight. It's probably in your home router. As you heard yesterday, it runs on the Raspberry Pi. It runs on big mainframe systems. It's been ported to the IBM mainframe. So, you know, it's everywhere. And why is it everywhere? Well, because it can be shaped to those different scales of systems. The reason it can be shaped to those different scales of systems is because it was released as open source. Microsoft has famously tried several times to do mobile, and they started off with Windows CE, which was kind of let's try and cram Windows into these smaller systems. Well, Linux, through the community, has managed to shape itself to all of these systems and to tablets and phones and things that we didn't imagine would exist back in '91. So open source as a philosophy works. Open source enables us to build systems that are enduring and can be shaped to all kinds of different requirements. So when we think about the cloud, I put it to you that having something future-proof or future-thinking, future-facing, customizable, extensible, able to adapt to the changes that we know will inevitably come. We don't know what new programming language will be invented tomorrow. Google's invented about 3 in the last 4 years, Dart and Go and all kinds of other things. We don't know what's going to come next from a language perspective. We don't know what will come next from a hardware or infrastructure perspective. So because we don't know that, it's really important that we choose a way of working and a platform that enables us to avoid that lock-in. And that brings me to my platform, Cloud Foundry. So Cloud Foundry as a project, was initiated by VMware a couple of years ago, 2.5 years ago now. VMware as a proprietary virtualization vendor started off by saying, well, here's a load of code, and we're going to make it open source and put it on GitHub. And we're going to aim at the platform space for cloud. So when we talk about cloud, we typically start to think about these kind of layers. And this is a fairly common pyramid type diagram you'll see in this space. So if we look at the software and infrastructure layers, infrastructure, everyone's heard of the fact that Amazon has a cloud. They call their compute platform Amazon EC2, Elastic Compute. Google has a similar offering now, Google Compute Engine. And then there's OpenStack in the open source space that competes with them. vSphere in the VMware proprietary space. And a load of other players around the edges who are either trying to copy Amazon's success, Eucalyptus tries to be API compatible, or go in a different direction as Apache Cloud Stack does. At the front end, what we as users consume, we're not all system administrators, we have the software as a service. Essentially, the web apps that we can run on that magic cloud. So the classic ones are things like Gmail and Salesforce. So in the middle, and I'm not saying that every one of those software platforms software packages is built on top of a platform as a service, we have this platform as a service space. And if you're not at all familiar with platform as a service, you may still have heard of some of these companies. Google has a product called App Engine, which enables you to deploy Python or Java or PHP or Go code. And Salesforce acquired a company called Heroku. Heroku is an excellent cloud platform, very, very popular, that many of you have probably heard of. How many of you are using these kind of platforms today, incidentally? Anybody? So Heroku users? Yeah. OK, App Engine, anybody? Yeah. App Engine's great. There's a couple of others as well, and Apprenda there is one that will sell you a private platform. So, Cloud Foundry is very, very specifically in this platform space. It's trying to let you deploy applications very easily onto infrastructure clouds and to scale them and manage them easily. Now, the interesting thing here is that out of the 4 or 5 that I've got listed, Cloud Foundry is the one that I've listed, which is open source. Most of the others in the space as a whole are closed source or proprietary. Google, when they first launched App Engine, would only let you run Python and Java code. And they had an issue that was open, I think, for about 2 or 3 years. Somebody saying, please add PHP support. And eventually, Google said, no, we're not ever going to do that. Now, as it happens, they have now added PHP support. But that's a number of years after App Engine came along. So we're in that space. What do we offer in that space? Well, several things. So first of all, because we're open source, you can run it. You can come and grab Cloud Foundry, run it or use Cloud Foundry provided by a vendor like Pivotal, who host their own Cloud Foundry platform that I'll show you this morning. So in the public cloud. And there are other vendors offering the public cloud offering. So, for example, The Pivotal public cloud runs on top of Amazon in the US. Many of my customers don't particularly want to run on an Amazon cloud in the US. So we have a company called Any9s out of Germany who are running a Germany-based and hosted Cloud Foundry environment. API compatible, exactly the same deployment surface. It looks exactly the same as deploying to our public cloud. But say, in fact, you're even more kind of paranoid about your data, and you don't particularly want it to be in a public cloud of any kind, wherever it may be in the world. You'd much rather run your own private cloud. And that's something that you can't do today with something like Google App Engine or Heroku. You're writing your code, deploying it to that public cloud. You have no behind-the-firewall option. So you can take either all of the open source pieces of Cloud Foundry and run them on your own OpenStack or a vSphere environment if you want to. Or you can purchase a prepackaged product such as Pivotal's Cloud Foundry. So we support the private cloud space as well. And finally, we have this concept of microclouds. A microcloud is essentially the ability to spin up all of the components and run them in a single VM on your local machine. So either you're disconnected, or again, you're even more paranoid. You don't even want it in your own data center. You just want it on your laptop. Or perhaps you want to help us develop Cloud Foundry as a platform and contribute to the open source project. You can run all of the components in a single VM. Now, of course, that's not elastically scalable, but it does let you have that local development experience exactly the same as you would have on the public cloud. From a language perspective, we support lots of them. I'm going to be talking this morning about Java and the associated frameworks in particular, but we also support the ability to plug in custom runtimes. So if you're a PHP or Python or Go developer, then you can go ahead and run your code, and I'll explain how that works in a moment. And most applications aren't particularly useful without some kind of data source or service, or even additional API that you might want to plug on the side. So I've already mentioned that Pivotal as a company sponsors the Rabbit and Redis projects, so we can use those services very easily on Cloud Foundry. But we can also plug in additional data services. And what this looks like to you as an application developer is simply the ability to look up your connection handle from the environment that you're running in. You don't have to do a bunch of configuration and set up yourself and consume that service. Depending on the public cloud vendor, you can also easily plug in other services. So Pivotal's cloud, for example, offers the ability to plug in SendGrid or New Relic or other popular third-party APIs. So we're open source, we're very flexible, extensible, and we want to provide as much choice as possible here. I don't know if you noticed on the back of the agenda booklet is in fact a mini version of JAX magazine. And one of the interesting things to me was that that magazine carries 2 articles that are both relevant to things I'm talking about. One of them is PaaS, and one of them is the Internet of Things stuff I'll be talking about later. But one of the things that Mike Sobey says in this article, and I'm not going to say that I agree with everything he says in the article, but one of the things that he writes is that we believe that the best cloud PaaS platform solution should be available on top of any cloud and not just, for example, Amazon EC2. Amazon's kind of semi-PaaS offering is something that they call Elastic Beanstalk. And we agree with that. As I said when I was talking about Linux, right? We don't know what an infrastructure as a service will be invented tomorrow. We don't know who, if anyone, will usurp Amazon in the future. And we do know for sure that you can't run Amazon's EC2 in your own data center, and you might choose to run something else. So we want to be as flexible as possible and to provide you that choice. So Cloud Foundry, in fact, will run on top of Amazon EC2, vSphere, and OpenStack. CloudStack support has just been contributed by NTT, actually, as part of the Cloud Foundry community. And in the future, I personally would love it for us to run on top of Azure or on top of any other platform that offers infrastructure as a service, because it gives you that flexibility and it avoids you being locked into any vendor that you may in the future fall out with. We give you all the pieces to make your own. Again, a bit of Lego theming here. So all of the code is available on GitHub. If you go and look at the GitHub Cloud Foundry project, it's kind of a bit alarming. There's a lot of projects there. So there's a lot of different pieces to the puzzle. And I'm not going to spend any time today actually talking about the architecture of Cloud Foundry as a whole. I'm going to ask you to trust me that it works. I'm very happy to talk to you outside later on about the individual components. But we do have ways of getting involved. We have mailing lists and so on. If you want to take a look and start contributing, we'd be delighted. And in fact, that's how the Cloud Stack support got started and has just been announced through the mailing lists. Fundamentally, what we're trying to achieve here is to move, in particular, the enterprise mindset, but in general, the development project mindset away from this kind of model, right? I imagine that many of you work for large IT shops or development shops, or have had experience with them. And what typically is happening, we're seeing in the industry, is that we've got these companies who do have these big IT and development organizations, and the CEO is tending to look at them and think, well, hold on a minute, if my son, who's in his teens, can write an app and deploy it to the App Store, and Twitter and Google and Facebook can update their apps twice a week, why the hell can't my enterprise IT department? Now, I know that you'll then, those of you who work in ops or have that experience will say, well, of course, we need to think about security. We need to think about, all of these requirements. And that's what a lot of these quality gates on this deployment flow are there to ensure. And that's absolutely true. But wouldn't it be nice if, instead of this kind of long 18-month deployment lifecycle for a project, we could actually simplify it to the point where we said, well, you know what? We've got a load of infrastructure. Let's say it's vSphere or OpenStack. That's essentially our hardware. What do we get when we look at an infrastructure as a service? We get some compute power, some CPUs, virtual or physical. We get some network, and we get some storage. And that's what enables us to run our apps. Wouldn't it be nice if we could just say, well, I've got all these boxes in my racks, and I'm running this virtual infrastructure on top of them. Now I want to deploy a platform. Let's call it like an operating system. That may take a few hours, but it shouldn't take weeks or months. And from a developer perspective, and I'll show you some of this in a moment, wouldn't it be nice if within seconds we could actually deploy our apps and have them running in the cloud? So I wanted to simply point at my cloud, target it, push my app to the cloud, create and bind to any data services I might need, and then when I suddenly find that my app has taken off and everyone in the company is using it, then I can simply scale additional instances. And so that's what I really want to quickly show you now. I'm going to, before I start talking specifically about our Java support, do a really quick tour of some of the features here. This is going to be fun. OK. In fact, let's go full screen. That's probably easiest. So this is actually myself logged into the Pivotal Cloud Foundry environment. So this is a public cloud that we host. It's our instance of Cloud Foundry. It is not the only instance of Cloud Foundry. There are many around. And I'll just get rid of this little warning message. So what are we looking at here? Well, we're looking at my dashboard. And I'm a user, and I can belong to one or more. Excuse me while I get rid of some of these things at the top. Is presentation mode going to help? Probably not. OK, well, I'm a member of an organization. It's my own organization, and we can think of that like a team. I'm also a member of my boss's organization, so if I was to look at that one, I would see lots of other users. But as it is, I can see over here on the right-hand side of the screen, I've added one of my colleagues to my organization, and I've given him some permissions. So, if you work in a team, you may have somebody who's responsible for deployment or testing. You may not want them to have the same ability to delete or create or whatever applications. So in my case, I've given Ferdy, my colleague here, just the ability to look at my apps, and I've got full access to do anything I want. Inside my organization, I also have a concept of spaces. And you can see them labeled across the top here, development, production, and staging. So I've got, as you can see below, a bunch of applications deployed in development. But if I look at my production space, that's actually empty right now. I don't have any apps deployed. So I've got separate environments which Cloud Foundry is managing for me on top of the infrastructure. So it's keeping my applications segregated from one another. If I look at my actual applications, I've got a PHP app, a Ruby app, and actually a couple of Ruby apps here. If I look at this one here, you can see this column that says instances and memory. This one here at the bottom has 2 instances. What does that mean? Well, it means that when a request comes into this application, it will be load balanced between 2 instances. If one of the instances goes down, there'll still be one there. If one of the instances does go down, by the way, we have a health manager which watches the applications and restarts them. If I click through, I can see that it's running. I can also see that as well as having my, my default URL, the one that we provide to all of the applications on the platform, I've mapped my own domain on top of it. And I can also see down here, it's not very busy at the moment, nobody's hitting my blog apparently. I've added a New Relic service to this particular application. Now, New Relic is a monitoring service, so I can go along and I can add different types of data service to my applications. So I've got, for example, the ability to load test, the ability to add Hadoop or SendGrid or so on. So I've got a marketplace there to easily bind my applications, bind my service to applications. So let's actually just quickly look at what this would look like to deploy an application. And I'm going to move that to a different space so I can actually read it. In fact, I'm going to make this full screen as well. That will make things easier. OK, so I've got, this is the command line equivalent of looking at that same view. And I've got a bunch of demo apps here. So node on. So this is a Node application written by one of our colleagues at a company called Tier 3. And it simply is using one of the Google APIs to do currency conversion. I have a file here called a manifest file. This manifest file is actually optional. It's very similar in some ways to the proc file that you'd use on Heroku. And it's specifying the name of the application, the memory, and so on that I would like when I deploy it. And one of the things I've done here, because every application needs a unique host name on Cloud Foundry, and I don't know whether somebody's already deployed something called currency, I've added a little marker to show that I'd like Cloud Foundry to generate a random word for me. So I'm just going to deploy this application. If that manifest file wasn't there, it would prompt me and ask me all the answers to the questions that I've already answered in the manifest file. But it's going to actually push this application now. So this one is Node, so it's using the Node JavaScript runtime engine. So it's uploaded it, and now what it's doing is saying, well, I know this is a Node application, so I need to install Node, and then I need to install all the module dependencies to run my application. This bit's a bit boring as we watch all this stuff go past. And then it packages up a little runtime environment that we call a droplet, and pushes that up to Cloud Foundry, and we're running. So I've got that unique name there. Let's just go and grab that URL, pop it into Chrome, and prove that we're running, I hope. Now, I was in Singapore last week, and I think I was paying about $10 for a beer. Is it SGD for dollars? Singapore dollars? I can't remember. If I get this wrong, I get it wrong. Oh, there we go. Perfect. So I was paying £5 for a beer in Singapore, which I thought was a little steep. I mean, it depends what you're getting, of course. So really simple, very quick to deploy. Hello.
Sorry.
Question?
Can I
Of course you can. Yes, please do.
When you deploy,
yes.
you have several environments defined. How would you?
Yeah, that's a great question. How did I choose? So by default, so the question was, I talked about those different environments, development, production, and so on, and how would I know which one I'm pushing to? So in my case, when I type CF target now, it will actually show me which target application space I'm deploying to. So in this case, it's telling me that I'm in my organization, a Piper org, and I'm targeting the development one. I can change that. So if I wanted to type CF target, I'm going to type CF help target because I can't remember the command line options. I think I can change the space. So yeah, -s would change the space. So I'm by default pushing everything into my development environment. Now, there is nothing special about that environment. The development environment, production environment, and test environment are just labels, and they look identical. So because it's development, it doesn't mean that it's any less powerful than the production one. But what I would find is, when I look at the dashboard, if I change to a different space, I would not see any of the services. So if I was, so in the example here, I'm looking at my development space. I'll just reload it to show that my app's deployed. Currency is now there. So I'm in the development space, and inside this, I've got a number of services at the bottom here with applications bound. So 2 of them are databases. Now, I don't want those databases to be visible in my production environment because they're specific to this development environment. So that's the only special thing about the environments. And furthermore, I can create more. So if I wanted to have an additional one called, I don't know, user test, it's simply just a question of adding a new space like that. Now, I do have a quota. As you can see at the top here, it's telling me that I'm in a trial period and I have a 2 GB overall application memory quota. I've got this. And if I was to look at my development space and total up the amount of memory that I'm using, I'm still within my quota. If you were to deploy Cloud Foundry inside your own company, you can set those quotas for your teams or individual developers very easily and keep control of your resources. So that was just a really, really quick tour, both of the dashboard and also the ability to push applications. All right, so that's a little bit about what we're looking at. Really easy deployment, really easy scaling, although I didn't show you that just there. If I wanted to add additional instances, it's a simple CF space scale app name and then the number of instances you want. And I've also shown you the fact that we're installing the runtime you need at the point of deployment. So in this case, it detected I had a Node app, installed the Node runtime it needed, then spotted that I had a package.json requiring a bunch of Node modules. It installed all of those for me using npm, and we were good to go. So in terms of Java, what I want to talk about, and I should also, sorry, let me just, with the greatest respect to my friend over there from Heroku, Buildpacks and what that enables, the thing that enables that dynamic installation of the runtime was some technology that Heroku actually came up with. So if you have used Heroku, you're probably familiar with the concept of Buildpacks already, particularly if you're wanting to add a language other than Ruby to Heroku, for example. And this is how we add this stuff. So we have our own Java build pack, which tries to make it as easy as possible to deploy things, but we can also use any Heroku build pack to enable that deployment for whatever application we need. One of the things we're trying to do here is to move the mindset to the idea of applications being at the center of deployments. So if I'm a developer and I want to write an app, then really I don't want to care about that whole other stack of stuff, such as the VM and the application server and so on. And I don't really want to have to go through the effort of configuring the frameworks and adding all the services. And if you look at the Amazon model in particular, you're a developer, you come up with a great idea for a mobile app, you rent an Amazon EC2 instance at medium or large or whatever size they offer you, you start running your app, it goes viral in the App Store, suddenly you've got thousands of developers, users I should say, hitting it. Let's call our app Instagram, and you've got billions of users suddenly. You don't want to have to clone that VM and set it all up again, and clone that VM and set it all up again, and then add a load balancer. In the first place, you're probably not actually using the whole of that VM resources that you borrowed from Amazon in the first place before you add a new one. So what we're trying to do is to use container technology. Who here has heard of kind of the concept of containers in operating systems, so like Docker and LXC and so on, yeah? So it's becoming very common. Docker in particular is very popular. We have a container technology called Warden, and that container is what runs our application. So when we created that thing called a droplet, when I did that deploy before, it pushed that droplet into one of these little containers. They're actually isolated from all of the other processes in the operating system. They're using Linux C groups and LXC to actually fence everything off. And we can make much more effective use of the underlying infrastructure because we can actually pack many, many applications into a VM without competing with one another because they're in containers, and make very effective use of that virtual resource. Now, the other thing here is that bottom layer, infrastructure 1, infrastructure 2, because in fact, I don't care where my app is running. I don't care if it's running on vSphere or it's running on OpenStack. I just care that my app is running. Those of you from the UK have heard of Comic Relief, I'm sure. Those of you who aren't from the UK, we have a charity drive here in the UK every 2 years called Comic Relief. It's one of these television marathons that the comedians come on in the evening and do lots of funny things, and we all phone up and go on the website and donate money to good causes in Africa and actually in this country as well. And if you think about the problem that they have, and you're probably wondering why I've gone off starting to talk about Comic Relief instead of talking about infrastructure. The problem that they have is that every 2 years, the IT domain changes significantly and the problem changes because suddenly more people have got smartphones and more people are either using SMS or not using the telephone or whatever. The whole interaction online and with their systems changes and the scale increases significantly. Suddenly people want to use Twitter hashtags to interact with the system. That's a really hard thing to build for the future. So this year, they actually chose to use Cloud Foundry for running Comic Relief. And they wanted to use the cloud, they wanted to be elastically scalable and so on, but they didn't want to be reliant on either Amazon or vSphere or OpenStack. So what they chose to do was to run on a couple of Amazon regions, not just one, because that would be bad, and then also run on vSphere in Europe as well. So they actually had Cloud Foundry deployed across 2 different infrastructures, Amazon and vSphere. The interface looks exactly the same. It's that same kind of CF command to push applications. It's that same dashboard I've just shown you. So the underlying infrastructure was not an issue. It didn't matter whether they were 2 physically different and geographically diverse infrastructures. Their applications could just run. And in fact, it turns out that they ran Comic Relief, the actual infrastructure, the actual applications this year for the first time without losing any transactions at all, which is fantastic news. So the thing that enables us to start thinking in terms of applications being at the center of our world here is actually the ability to push these apps into these containers and to support them using Buildpacks. And I've talked about a couple of terms here. I've talked about Buildpacks and I've talked about droplets. So that when we do that initial push that I showed you, we work out all the dependencies, we package it all up using the Buildpack, and we get our container and our libraries and our runtime. In the case of Node, our runtime was Node. Our libraries were all the NPM modules, the Node modules we needed. We didn't have a container as such. In the case of a Java application, you might be thinking about the JVM, which of course might be the Open JDK, or it might be the Oracle JDK, or it might be the IBM JDK. You'll have any libraries you need, and you may have your container, which may be, I don't know, Jetty or Tomcat or WebSphere or WebLogic or whatever. We package all of that stuff up into this reusable thing called a droplet, and that droplet is what actually executes inside our engines on the cloud. So this whole concept of Buildpacks is really important, and we do follow the design that Heroku came up with for Buildpacks. Buildpacks are actually 3 scripts. Heroku's website's got some fantastic documentation on how to build your own if you want to add support for Haskell or Fortran or whatever you want to run on the cloud. And so we are compatible, although as the footnote says here, if you take care to make them compatible, because there are some architectural differences between the 2 platforms that make it possible for Buildpacks not to be compatible. And in fact, both Cloud Foundry and Heroku are not the only people doing Buildpacks. There's another little open source platform as a service called Flynn, which is actually related to Docker, which is also using Buildpacks. So we believe this is becoming an emerging convention and a good way of actually deploying apps in a reusable way. So Cloud Foundry comes with 3 Buildpacks, 2 of which, as you'll notice from the name, are directly borrowed from Heroku. The Node and Ruby Buildpacks are essentially just forks of the Heroku one. And we also have our own Java one. And the Java one is something that we focused a lot on because as a company at Pivotal, we have inherited all the Spring Source technology. We're big Java fans. We're big Groovy and Grails fans. So we've really wanted to make the Java experience very, very easy. Built in here, by the way, means that by default, if you have an app in any of those 3 languages, you can just push it to Cloud Foundry and we will detect what you're doing. If you have an app written in another language, PHP, for example, then you need to provide the URL to that build pack when you do that initial CF push. We also have a wiki where we are kind of coming up with a list of other build packs that we know will work without changes on our platform. Things like Clojure, actually, although they're JVM-based, have some additional things that you might want to do within a build pack. So these aren't necessarily endorsed by Pivotal, but they're known to work, and the community is writing them up. So the Java build pack tries to be very modular and tries to be cognizant of the fact that, as James Governor spoke about in yesterday's keynote, the Java landscape is much more diverse than it used to be. And that's a great thing, right? We've got lots of different languages emerging, running on the JVM, lots of different containers, frameworks from kind of the big complete ones to the very lightweight ones. And we want to enable developers to just go ahead and write their code and get it to work. And Ben Hale, one of our Spring engineers, who's responsible for the Java build pack, wrote a great blog post when we announced the new Java build pack. And I love the philosophy here. We want this to just be the easiest way for you to run a Java application, for you not to have to download a container or an app server, configure it all locally, fiddle around with XML files in Tomcat or whatever you might need to do. We just want you to be able to write your code, compile it, push to the cloud, and run. So I spoke about those concepts within the build pack before, the fact that we need a runtime, in this case a JRE. We potentially want a container, and also want to be able to support different frameworks. One of the frameworks there is New Relic, incidentally, and New Relic isn't really necessarily a framework. It's just a library. It's an agent that talks to the New Relic service to enable it to monitor your app. And what we're saying there is within that framework section of our build pack, we can insert additional code. So in fact, when we push an app to Cloud Foundry, it will look to see whether you've got a New Relic service bound to it, and if so, it will inject that agent for you. You don't have to do any additional configuration. How does all this work? Well, there's a bit of introspection going on here. So we do a bit of looking into the app to work out what we've got. So if we've got a manifest with a main class, then we assume it's just a plain Java app. If we've got a web imp, we're going to use Tomcat, for example. And you'll notice I'm being very specific in saying Tomcat and not other app servers at this point. Spring Boot I'll talk about in a little bit. If you haven't been following the developments in Spring, you may not be familiar with Spring Boot yet, but I'll talk about that briefly in a moment. And obviously, if you've got the Play framework there, then we're going to assume you're a Play app and you're going to need a container for that. Then we also do some framework detection, so we try and work out what you're doing. This is not foolproof, by the way. I mean, we do our best, based on these kind of criteria, to figure out what you need for your app. Sometimes it may need a little bit of additional help, and you might need to pass in some command line parameters. But generally speaking, again, based on Ben's comment, we're aiming to be the easiest, simplest way of getting your app up and running. So I mentioned just Tomcat. And what if you don't want to use Tomcat? What if you want to use your own? Well, you can customize the build pack. So you can fork it on GitHub and change the artifacts that are being used. And then you can also add your own frameworks and libraries. So again, if you weren't using New Relic, but you had some internal monitoring tool that always needed a particular agent installed, then you could insert that into the build pack so that when your developers push their apps to your cloud, it always got auto-configured that way. There's really, really good documentation in the repository on GitHub for the build pack in several parts, talking about all the different ways you can customize it. Now, in particular, before I joined VMware and Pivotal, I worked for IBM for 10 years. And IBM have recently joined the Cloud Foundry project as contributors. And one of the very first things they contributed was a build pack for their lightweight web server application server that they call Liberty. The way that they developed that was they actually came and worked with us. We are heavily into pair programming as a company. So they came and paired with us in our lab. They learned how our build packs worked, how Cloud Foundry worked, and they built their own build pack. Now, in their case, they don't like to use the OpenJDK for whatever reason. They like the IBM JRE. So they install the IBM JRE, and then they install WebSphere Liberty. So you can just go ahead and take your existing WebSphere apps and use their build pack. There are other forks adding additional containers like Jonas. Unfortunately, I haven't seen anybody step up to offer JBoss or WebLogic support yet, but we'd love to have that available as well. What about tooling? Because we all want to do a lot of automated stuff here, automated deployments, as you mentioned earlier. Well, we've got tooling support, and in fact, looking at the data on this blog post, you'll notice that this was actually just yesterday. We announced improved tooling support. So we support both Maven and Gradle. We have tasks there which enable you, as part of your build process, to automatically push your apps to Cloud Foundry. And in fact, the tasks are much broader than that. So they can do things like listing what apps are already there and deleting things and logging into Cloud Foundry as a different user and so on if you needed to. So really, really complete, very nice support there. We actually use Gradle for all of our work in the Spring framework, and we're seeing that obviously adopted by people like Google for Android as well. So a lot of popularity around Gradle and momentum there at the moment. We also have plugins, and I don't have a screenshot, and I'm not going to demonstrate them, but we have plugins for Eclipse that we maintain that enable you to really easily deploy to Cloud Foundry as a server-side environment. And there's also IntelliJ support, which those guys work on as well. Right, I'm going to do another demo in a short while. Before I do that, I know not everyone in the audience, well, I know at least one person in the audience, are not Spring fans. How many people here are Spring developers? Just curious. OK, cool. Ish. Oh, now it comes out. Reluctantly. Well, so I don't know if you've looked recently, but we relaunched Spring, if you like, or we moved it to a new home. Spring.io is the new website. And this is it. It's written in Spring, and it runs on Cloud Foundry. And in fact, we made it live at the Spring One conference in California last month. Chris Beams from the Spring team, against all advice, did a blue-green deployment, actually, and made the new thing live on stage at the event. And of course, it then got hammered, but it stood up very well. So Spring.io. Spring.io is the name of the website, but it's also the new name of the framework. And in fact, what we are doing with Spring, what the organization has been doing with Spring, is doing a lot of reorganization, recognizing that it had become this is me saying it the nice way, it had become a very rich framework with a lot of different function, and really trying to make it much more modular and easy to consume. And we do that in a few ways. One of these ways is through something called Spring Boot, which I'll talk a little bit more about in a moment. But the other way is simply by focusing more on scripting languages like Groovy as a domain-specific language. And also really by trying to make the whole framework much more easy to navigate and learn about. So what's this Spring Boot thing? Well, Spring Boot is really a reaction to the fact that, yes, Spring has lots of libraries and richness of function, and in fact, it could be quite daunting to get started with if you looked at the whole thing all at once. So Spring Boot tries to take a very, very opinionated view of writing Spring applications. And it gives you can create a little Spring app very, very simply, and it will do as much as it can to help you and do things for you. So we have a little command now called Spring that you can install, and then you can literally do Spring run application, and it will do things like configuring all of the web server you need and installing all the libraries for you. What does this look like? Well, in fact, you can do some really cool stuff with this. And if you came to Guillaume's talk yesterday, he briefly mentioned this himself. You can now fit an entire web app inside a tweet using Spring and Groovy and Spring Boot. So some of the engineers started to compete to see who could build the simplest Spring Boot application. Rob came up with this one, and then Greg came up with this one. And in fact, he's got @replies in here as well. So he's not even using it very effectively. And then we could do this kind of thing as well. And I'll show you this in a moment. We can literally get that code without the @winch at the top, paste it into a Groovy file, type Spring run app.groovy or whatever, and it will start up a full web environment for you. The other thing we're doing with Spring is really trying to focus on the fact that the future, if it isn't already the cloud, is the cloud, right? So one of the goals of the Buildpack, in particular, is to enable it to auto-configure Spring apps for you. So what we do is we look at them and try to apply the right profiles and configure the right connections to all of your data sources to actually get your code running without actually having you change anything. There's no need for you to do sort of scripted inline replacements for config variables and things. So with both Spring and Grails, with our Java build pack, we can enable this auto-config. But this all sounds very, very Spring-centric, and as if we're trying to lock you in. And I said all that stuff earlier about lock-in is bad, and I believe that. So the other thing that we did recently was announce a new project under the Spring banner called Spring Cloud, but it does not require anything else in Spring. It does not pull in lots of other dependencies. It does not mean that you're using Spring. Spring Cloud is a new project which tries to make portability between different cloud platforms very, very easy for you. Again, the documentation's in the GitHub README, but what we want to be able to do, for example, is to abstract away through the Cloud Factory the different cloud environments we're talking about. So in particular, we support both Cloud Foundry and Heroku using Spring Cloud. If you were to use Spring Cloud in your application, then it would run on either Cloud Foundry or Heroku and be configured for the right environment variables and so on that you might need. So you could very easily move between those. And in the future, we're hoping that we'll have adapters for other platform as a service environments, maybe App Engine, for example. So this can be used from any Java app. Spring Cloud, go and have a look. It's a pretty nice little project. So I've talked a lot, and I'd much rather show you some stuff. So I'm going to show you a few bits and pieces, if I may. I've got about 10 minutes left. First of all, let's have a look. That's probably not the right terminal to use. Let's see if I've got a better one. There we go. Let's go and have a look at that Spring Boot demo I was talking about. So just to prove there's nothing up my sleeve here. Oh, I'm sorry. I should have mirrored my display. Brilliant. Thank you very much. Thank you. I promise there's still nothing up my sleeve, although I was typing just then. All I've done is gone into my directory with my app, app.groovy, and put it on the screen. So you can see it's essentially one of those tweets that we saw earlier. So if I was to now type spring run app.groovy, the Spring Boot will start up, go and start up my application in 2.314 seconds, and I'm now listening on 8080. And there's my Groovy app. So that's running locally using Spring Boot. Not particularly exciting because it's local. So again, all I've got here is app.groovy. I've got nothing else. If I type cf push, now this time I don't have that manifest file. And I mentioned before, if you don't have a manifest file, it will prompt you. So let's call this JAX Groovy or JAX Boot. Let's call it that. One instance is fine. Yes, don't need any more memory than that. That's fine. Just that default domain. Don't need any services, no data involved. Don't bother saving it. If I did save it, then that would create that manifest file we saw previously. Now this is the bit where there'll be a little bit of uploading over the Wi-Fi and the internet, so I do some jazz hands and interpretive dance whilst we wait for things to happen. So in this case, instead of Node, we're downloading an OpenJDK JRE. We could choose a different one. We can modify the build pack to, instead of selecting 1.7045, we could have it install one of our choice. We're grabbing the Spring Boot command line that we need, creating that droplet, and uploading it. And it's just starting up on the cloud. And that end-to-end has taken a little longer than the 2.4 seconds it took to start on my laptop. But in just a moment, if you have a browser and go to jaxboot.cfapps.io, then hopefully you'll see a hello world once it gets to the running point. Running, there we go. So we're available. Not particularly thrilling because it's just a hello world, but we've deployed an app very, very simply there. I didn't need to tell the build pack, hey, by the way, this is a boot app. By the way, it's a Groovy file. This is what you need to run it. It just figured it all out for me. OK. I'm just going to get rid of that app so that I don't run out of quota when I do another demo in a minute. Yes, delete, die, go away. Right, in the meantime, let's have a look at something a bit more complicated. So, Spring Music should do nicely. Spring Music, we actually have a repository on GitHub as well as the Cloud Foundry organization. We have one called Cloud Foundry-samples, where you can get lots of different sample and demo apps, and Spring Music is one of those, written by my colleague Scott. So this has got a Gradle build set up. In fact, it's one of the apps that Scott mentions in his blog post yesterday about the new Gradle support. So if I wanted to, I could use Gradle to fully build this app and push it to Cloud Foundry now, because there is a rule in the Gradle file which would do that. I'm actually going to do a manual push of this app, but I have already built it, so we won't be waiting quite as long. CF push. It's going to go ahead and look at that manifest file, work out that I need a new app called Spring Music. It's created, again, it's got that little random word thing in there so that I'm getting definitely getting a unique URL. And then we wait while it uploads. And again, this time, we will see it, instead of installing Spring Boot as a dependency, it will just install the bits of the Spring framework it needs, I hope. And this one does look a bit more exciting than Hello World, but only just. So again, we've got the application package. We're grabbing the JDK and so on from our cache on S3 there. Downloading Spring Auto Configuration. I mentioned that we are going to try, as we go, and auto-configure anything that might be required from a Spring perspective. We've also installed Tomcat here. Pushing the droplet up to Cloud Foundry. And that's going to start up. And we've started very, very fast, actually. So let me go and look at this URL, because then I can start to do some more interesting things. So this particular one is just a music collection. But when it loads, come on, there we go. So we're going to have a bunch of albums and so on, which we can sort in different ways, particularly exciting. But if we hover over the little eye here, you'll find that we're using Spring profiles, and it's detected that it's running in the cloud, so it's applied the cloud profile it needs. And the other thing is, it says is in memory. Well, this has got a bunch of data, right? It's got a list of data here. So it's currently using the in-memory profile to manage that database. And if I was to delete things, restart the app, they'd come back because it'd be populated from code. So wouldn't it be interesting if I, instead of doing all of this in memory, I was to use a database? OK, let's do that. Let's go ahead over to my console here, refresh it so that my Spring Music app shows up. And let's add a database to it. No bound services right now. I'm going to create a new one, actually. Or can I use one of these already? No, I'm going to go and create a new database, because I can't remember if those are all in use. Urgh. Let me click. Right, Chrome. You're just being annoying now. There we go. So actually, I'm going to choose a Postgres database, but I could choose a Mongo. We've got a Mongo lab as well. So it will support both SQL and NoSQL databases, this particular app. So I'm just going to grab a new database, assign it to my development space, and assign it to my Spring Music application automatically. So this is now going off to Elephant SQL, who are the third party that are providing our databases on Cloud Foundry, on our hosted Cloud Foundry, provisioning me a database, and then it's going to assign it to my Spring Music app, I hope. OK, created. And then it mentions that I need to use CF push. So in this case, because it's got a new database and the app is still running, it's not necessarily aware of it. So let me just go back and look at Spring Music and see that it's got that service bound, which it has. I'm also going to add, go back to the marketplace, and I'm also going to add New Relic as well. I'm aware that we are just at the end of our time, so I will be quick, I hope. OK, New Relic is not playing with us today, so in that case, I'm just going to leave it with the database. In the meantime, let me just do CF push again, just to refresh what's running. And I'm hoping, if all goes according to plan, that we'll find that this time the build pack will detect that there's an Elephant SQL instance bound to the application and install the relevant drivers I need. And then we'll see that the application is dynamically changed on the server side. Or simply changed, I should say. It's not particularly dynamic because we're stopping and restarting it. So we've grabbed stuff from the cache. I'm not too happy about that. I don't think you've detected that I've changed it at all. Don't lie to me, Cloud Foundry. I was expecting to see the SQL driver. It may already have been in the Spring dependencies that have been installed. Let's find out. OK, good. So now this time we know that we've got a Postgres database attached, and we're using the music service, which is the name of that database I created. So this time, if I was to go ahead and actually change the stuff and restart the app, then in fact we'd still see that that was persistent because it's in the database. OK, so finally, to round all of this off. Turn that off, give me my slides, and race towards the finish. Finally, very, very quickly, wouldn't be particularly good advocate if I didn't suggest that you at least give this stuff a try. If you do want to try it and you want to get through our approval process quickly, because you'd be amazed at how many people try and hammer a free cloud computing resource for spam accounts. Then do come and find me, and I can give you an invitation code that will get you straight in. More importantly, if you try it and like it, or even if you're just intrigued by what I've been talking about today, I would absolutely love it if you come and join our community and get involved and work with us. There's some really cool stuff that's been happening. We've had SAP and IBM join the project, as well as Piston, who are one of the OpenStack supporters. And NTT from Japan are also contributing lots of cool stuff. So I'd be really keen to have more people involved in the community. And that's me. So if you want any more information, have any questions, I didn't make myself clear on any particular subject, please come and either ask me questions now or reach out to me on Twitter. Sorry, I just used that reach out to me phrase. I hate that phrase. Why can't we just say contact me? Contact me on Twitter or email, or whichever way is appropriate, preferably without throwing heavy items, because I'm very accident prone. Anyway, thank you very much for your attention. And if you do have any questions, I'll be happy to take them, or we can head for lunch.